Geographers, welcome back. Video number 2 for Key Area 1 in the water cycle. This lesson we are going to study 5.2 A and B from the specification. So just to recap on the last video was all about the global hydrological cycle. Yep. So we're thinking in terms of a closed system at kind of planet Earth kind of scale. This part of the spec, 5.2, is focused more on drainage basins. All right, so individual rivers and at a more kind of local or regional scale. And the idea that the drainage basin is an open system, so inputs of water can come into the system. There's different flows, what transfer and move that water within different stores within that drainage basin system, and then water can also leave through outputs. Alright, so what we're going to cover today is this part of the spec, 5.2a, which will take a while, and then 5.2b, which will be a lot faster. Alright, so this is the kind of meaty 5.2 is the meaty part. 5.2b, I'm going to cover that much quicker because we're going to do some higher level stuff in lessons with that. So 5.2b is just going to be a list of different factors. Alright. Have a look at your learning objectives then. So I'll kick off with the fact that a drainage basin is an open system. Alright, so we've got inputs into the system, we've got flows within it and transfers, and then water can also leave as outputs. You're going to be able to name and define the input, 7 flows, and the 3 outputs. We're then going to focus on inputs for quite a while. The different types of rainfall and what causes rainfall and precipitation. Alright, and we're going to be able to sequence and explain the 3 different types and have a bit of an idea of where the 3 types of rainfall would happen as well. Alright, then that will take quite a while. What will happen quicker is the characteristics that affect the precipitation and the inputs, and you're just going to be able to simply name 5 physical factors that affect inputs, flows and outputs, and I want you to do a little bit of thinking before the start of the next lesson in class of which processes are affected by each one of these factors. Alright, keywords that you need to know or define by the end of this video are listed there. Okie dokie. Right then, so I'm going to kick off with a couple of graphics and 3 key terms. So if you've never studied rivers at GCSE, don't worry, not a problem. So at a more kind of regional, national, smaller scale than last lesson, we're going to look at drainage basin. So what is a drainage basin? Well, the definition of a drainage basin is the area of land drained by a river and its tributaries. So if we look in terms of this graphic, all of this land is drained by this river channel that I've just highlighted. Now what that means in layman's terms is if it rains anywhere inside this area, eventually that raindrop, that water, will make its way into the channel. Alright, it gets there in different ways. Sometimes it's over the surface, sometimes it's via tributaries, sometimes it's through the soil or the ground, but the area of land drained by a river and its tributaries. If you look at a real world example of the Mississippi, all of this area of land here is the area that river drains. Alright, next keyword, so I should not tick, tributary. A tributary is just a smaller river or stream that flows into the main channel. Alright, you can see them listed or shown just there and there. Now for some of the world's major rivers, the tributaries are quite large and significant rivers in their own right. So for instance, the Mississippi River has tributaries feeding it which are large rivers themselves. The Ohio, the Tennessee, the Red, the Arkansas, the Platte. Yep. So it's a smaller stream or river flowing into a main river. The watershed is, well, this red line that I've actually drawn on, it's the boundary or the dividing line between one drainage basin and another drainage basin. Alright, and reason why I've used Mississippi an example, because there's one of the world's most famous watersheds called the Continental Divide, which I've actually seen this summer on holiday, and it's a high ridge line whereby if it rains to the east of the Continental Divide, that water drains probably into the Mississippi and ends up in the Gulf of California. If precipitation falls to the west of the Continental Divide, it will end up in rivers like the Colorado and either flow into the Gulf of California or the Pacific. Alright, so the watershed is often it's on high ground. It can be a ridge line in a mountainous region, for instance. If it rains to the west of the ridge, it will end up in a different drainage basin if it rains in the east. Alright. Right then, well, the drainage basin is an open system, so that means that inputs of water can flow into a drainage basin, and there's mainly one input that we are concerned with, and that is precipitation. Alright, so input. If water can enter a drainage basin, then it can also leave it, and there's three ways how water can leave a catchment area or a drainage basin. The first one is it can actually flow or run in the river channel into the sea or into lakes, alright, or another river drainage basin. That's one way it can leave. Another way is it can evaporate into the atmosphere and then get carried outside of the drainage basin by winds. And another way is it can leave vegetation and plants and evaporate out of plants into the atmosphere as well. Alright, so what you need to do, make a brief sketch of this kind of graphic. Don't worry about being Pablo Picasso or Van Gogh or any other world famous artist. That's not what it's about. Simplify your sketches, folks, but by the same token, don't draw them so small that you can't label or add things under the size of a postage stamp. Yeah, so good, probably third to half a page. Alright, you might want to also create a key, color coded key showing inputs, outputs, and in different colors, and then the flows, what I'm going to discuss now, in a different colour again. Right, then the first flow or transfer, there are 7 in total, and these are important in transferring precipitation that has fallen to the land into the drainage basin and out of it. So the first one, if you use a bit of logic, is interception, alright, by plants and vegetation. So the keyword interception means precipitation that does not reach the soil. So it can sit on the canopy and the leaves and the trees, and some will evaporate from the canopy back into the atmosphere as an output. Alright, that's the first one. The second one, if rainfall does make it to the ground surface, well, it can do a couple of things. One is it can flow over the surface as overland flow or surface runoff. Both those terms mean exactly the same thing. I don't care which one you use, and I'm going to switch between the two in class. You just need to be able to recognise and be confident using either or either one. And the definition of that is it just means water travelling across the surface of the land but not in the river channel. Alright. Number 3 is infiltration. So infiltration is water that kind of penetrates from the ground surface into the soils. All right, and the way I think about this is kind of like James Bond. If he's penetrating the KG or infiltrating the KGB, for instance, then he kind of breaks in, finds his way into it. So water infiltrates from the ground surface and breaks through into the soil or rock underneath. Number 4. Once water has infiltrated into the soil, it can travel through the soil. And strictly speaking, the term for this is through flow, but so you don't get mixed up, if you put soil through flow, then you're never going to forget that soil through flow is when water travels laterally, sideways, through the soil. Alright. Number 5, percolation. I think in this example it's called recharge, and there's another little extension of that arrow from infiltration which we're going to label percolation. And I am terrible at writing with this pen. I need to buy a proper pen, so I do apologise. Percolation. Definition of percolation, not meaning of it, just means transfer of water from soils and surface rock into deep bedrock. And I think, so I don't get these two mixed up, I think of a coffee percolator, where it's filtering through soils and rock. Alright? So just think filter, and you won't go wrong with that. Number 6 is groundwater flow. So once that water has infiltrated, then percolated into deep underlying bedrock, it can stay as a store if it's static, but often it's moving very slowly, alright, towards the river channel. Groundwater flow, also known as base flow, it's the transfer of percolated water through porous and permeable rock. Alright, so not all geology, not all rock or lithology, not all lithology, will let water pass through it. So only different certain types of rock. Sandstone is an example. Keyword number 7 is river or channel flow. Now, if it's water's flowing in the river channel within the drainage basin, then it's a flow. Once it leaves that drainage basin, it'd be an output. This keyword can also be called river flow, channel runoff, whatever, whichever one, it doesn't really matter. And it just means the flow in the river channel itself. Alright? Right, folks, so the only input really we're concerned with is precipitation. And there are 3 different types. So give it a subheading, inputs, and then orographic or relief rainfall is the first type. Relief just means the height and shape of the land. So it's something about the land that causes rainfall. Alright, and you need to do a quick little sketch of this graphic. Again, we don't need to be Pablo Picasso. Outlines will do. It's the understanding of the labels that are clear that I'm probably more concerned with. Right then, so Atlantic Ocean to the west, compass directions are always useful. We've got the North Sea to the east. This is a cross section of the UK. We've got cities like Manchester, Sheffield, Lincoln. Right then, so what happens is prevailing onshore winds blow over the Atlantic Ocean for thousands of miles, and they pick up moisture. Collect moisture. So it's a moist onshore wind. Now when that onshore wind, prevailing wind, reaches the land, it can't go through the land, so the shape and height of the land causes that wind to rise. Again, use a bit of logic. What happens when you walk up a hill or you walk up higher up a mountain range? It gets colder. And that means that the moist air cools and condenses. So moist air cools and condenses as it rises. This then creates, bad drawing time folks, rainfall. And one thing to bear in mind is a kind of prerequisite to get any kind of rainfall. You basically need moist air to cool below the dew point and below the saturation point. Now the easiest way for that to happen is if air's forced to rise. So just think, what causes air to rise? Well, the first thing is the land, alright? And most of the rainfall in the UK is on the windward side of the UK. So the windward side is the side of the UK, the west, where the prevailing winds are blowing from. Another key bit of evidence that's easy to remember, 90% of the rainfall is found on the windward side. Alright? Once that air is deposited most of its rain, then it descends over the other side of the mountain, but it's quite dry at this point, and this is called, a bit like with coast topics, you probably heard me refer to this word, the leeward side, alright, which just means the sheltered side. Now on the leeward side tends to only receive 10% of the total moisture that gets deposited through relief rainfall. Alright, and there's another key word that I want you to remember, and the examiner will probably be running around the room thinking, oh my god, I've got an awesome geographer on my hands here if you mention the word rain shadow, because only 10% of relief rainfall falls in the side, and we say that area is in rain shadow. Now if we think in terms of drainage basins, obviously, which are going to receive higher inputs, it's going to be the west parts of the UK, which are going to receive more susceptible to drought. It's going to be the southeast. And this graphic, I like that word graphic, don't I, folks? I must think of, get more original and use something else. But that's what it is, I guess. This graphic shows the rainfall amount averages from 81 to 2010. You can see, the highest values are blue. Where is it? It's the western side of the UK, the ones facing large body, well, the largest ocean, because the prevailing winds come from the west. Gets deposited over mountain regions like the Welsh mountains, the Pennines, the Cumbrian mountains. I think the Cumbria is the wettest county in the UK, so that's why, or one of the reasons why. And then as the air descends over the southeast of the UK, it's a lot drier. So which parts of the UK are more susceptible to drought? London, southeast, and Kent. Another subheading, folks, the second type of rainfall is convectional rainfall, and I've kind of done the job for you here. I'll just talk you through it, but yeah, if you can sequence it off the top of your head, that's where we need to be. So basically, convectional rainfall is caused by solar energy from the sun, which tends to be the highest in all parts of the world, midday to early afternoon. Alright, the sun then heats up the ground, which causes ground heating and that causes the air to also be heated. What happens to warm air? Well, it rises and it evaporates, picks up moisture, evaporates water from the ground surface, from soils and from vegetation. That moist air then, warm air, rises, just like in a hot air balloon, and it cools and condenses very quickly. Alright? If the solar energy is really intense, then it can rise as much as 25 meters a second. So it's rising super quick and it's cooling super quick. So we get these cumulonimbus storm clouds forming. Cools and condenses below the dew point, below the saturation point, and we get rainfall. Now, if we think of certain case study examples, little examples of where we find this type of rainfall, well, one of them is kind of very humid tropical regions. Think Amazon rainforest, where the water cycle is, I think of it as being primarily up and down every day. 12 p.m. the sun comes out, heats the ground, water vapor evaporates, rises, cools and condenses, thunderstorm. Next day, same thing. Yep. The climate is pretty steady all year round. It does have slight seasons, but whether you go in December or go in June, you are going to get wet in the early afternoon. It is going to rain. All right. Other places where we get this type of rainfall is actually in the UK in summertime. If we've got a lot of moisture in the soils and on the surface, and then it's really sunny, it can kind of power this convectional rainfall process. All right. The third way, the third type of rainfall is frontal rainfall. Can also refer to it as cyclonic rainfall. So what else then can cause warm, moist air to rise and cool below the dew point and below the saturation point? Well, we find large bodies of air that have got uniform characteristics. And all I mean by that is you can have a warm air mass, which is a large body of, well, in this instance, we'll say it's warm and wet air, and that meets a large body of cold and dry air. Where these two air masses meet, we get what's called a front forming. And there are different types of front, and we'll look at those later on in the course, but we'll just stick to the basics for the time being. If warm, moist air meets cold, dense air, logic tells you the warm, moist air wants to rise upwards and the cold air wants to descend or sink. All right. So again, follow the logic through. Warm, moist air rises. What happens to it as it rises? It gets colder. It cools below the dew point, cools below the saturation point, and it rains. So wherever we get a front, it's pretty much guaranteed you are going to find some type of rainfall. All right. Again, where does this happen? Many places across the planet, wherever two different air masses meet. All right, driven by weather systems, which we'll get onto later on. Right, folks. Hopefully you've got kind of 3 or 4 sketches fully labelled with your keywords, and you've been able to sequence them through. Last 2 slides are going to happen pretty quickly because we're going to do a lot more work on these in lessons. Start thinking how different characteristics affect inputs, the different flows and outputs. So I'm just going to give you the characteristics, and all I want you to do for a bit of homework is see if you can name or think of how or why each one of these characteristics affects a particular input flow or output. So what characteristics affect inputs, which is precipitation? Well, the type and form of precipitation. So is it rain, is it snow, or is it hail? Obviously, one of these will travel or flow or flux much faster than the other one or two. Try and think which ones will move slow and which ones will move faster and why. The amount of precipitation, so how much a drainage basin receives, at a more local level. How intense is that precipitation? Is it a short burst and kind of thunderstorm, or is it more kind of steady and drizzle? So the intensity can affect how a drainage basin responds. The fourth one is seasonality. So some parts of South Asia, for instance, India, Bangladesh, that receive monsoon rains, most of their rainfall will come in 4 months of the year. And number 5 is the distribution of that rainfall within a drainage basin. This is significant for your world's major rivers with very large drainage basins. Example, think of the River Nile, the River Mississippi. It flows through they both flow through different climatic zones because they're thousands of miles long. So, how that river responds and drainage basin responds will be different in different parts of the basin. Yep, and that'll have an overall impact on the channel flow in that river. The next slide is subheading 5 physical factors that affect processes within drainage basins. And I want you to just be thinking before next lesson, well, how does climate affect inputs, some of the processes, and outputs? Climate concerned primarily with precipitation levels, rainfall levels, wind and temperature and seasons over a longer period of time, at least 25 or 30 years. The second physical factor or natural factor that affects drainage basin processes is the type of soil. Again, just try and link it to a process. Which process would be affected by the type of soil? Third is the geology, the rock type, and the lithology. Porous and permeable rocks, very different to impermeable rocks, for instance. 4 is the height and shape of the land, which is the relief, and also the steepness of the slopes as well, and the gradients. So again, try and link it to inputs, processes and outputs if possible. And the last one is the type and amount of vegetation, and I've put this kind of biome map, this world map of different biomes, just to show that we've got different types of vegetation. So that's a bit trickier, but you could have a think about how that links in as well. All right. Right then, if you want to be an absolute superstar, you're responsible for your grade. Take some ownership over your learning. Where can you do some further reading on 5.2 A and B in the spec? Pages 8 to 10 in your study guide number 3, 12 to 13 in the dark blue book as we call it, 12 to 13 in the grey book, and I've been lazy, I've not put it on for the last one, so you're going to have to do a bit of digging for that. Alright, bring a good set of notes, some sketches to next lesson, and have a good one, folks.